Ladies and gentlemen, esteemed faculty members, and my fellow students, a very good afternoon to you all. It is with great pleasure and excitement that I stand before you today as we gather for the much awaited ChemTalk 3, organized by the IICHE Students Chapter AVVU. This platform has consistently served as a beacon of knowledge and learning for our budding chemical engineers, and today we are truly honored to welcome a distinguished guest speaker who undoubtedly illuminate our minds with his expertise and insights. Before I introduce our esteemed guest speaker, Mr. Chiranjeevalu, allow me to take a moment to reflect on significance of events like these. In a world driven by constant advancements in science and technology, it becomes imperative for us, the future torchbearers of the chemical engineering fraternity, to stay informed, engaged, and inspired. Chem Talk as a series has been instrumental in fostering this spirit by bringing together accomplished professionals, curious minds, and the thirst for knowledge under one roof. He holds a science degree from Andhra University and was awarded a diploma in mechanical engineering from the State Board of Technical Education and Training. In the initial phases of his professional journey, he worked with Andhra Oxygen Limited and Andhra Petrochemicals. Mr. Chiranjeevalu boasts an extensive career spanning over 35 years, with the majority of his professional journey dedicated to serving Mangalore Refinery and Petrochemicals Limited in the capacity of Quality Control Department for an impressive 24 years. He culminated his career at Mangalore Refinery, retiring with the distinguished title of Chief Engineer and various other achievements. Let us make the most of this occasion by being attentive, inquisitive, and open minded. Let us seize the opportunity to absorb wisdom from Mr. Chiranjeevalu's journey and apply it to our academic pursuits. With the events like ChemTalk 3, we are not just attendees, but active participants in shaping the future of chemical engineering. We are honored to welcome Ms. Dr. Nikhil K. Korturkar, the distinguished head of the Department of Chemical Engineering and Material Science, to our gathering today. Dr. Nikhil is widely recognized as an authority in polymer science, and his significant contributions has played a pivotal role in bringing this event to fruition. His unwavering guidance has been the source of support and inspiration, aiding each of us in our journey of personal as well as career growth. Furthermore, I would like to extend a warm welcome to all the esteemed faculty members and students who have joined us today. Your presence here truly enhances the greatness of this event, and we are honored to have you here to share this experience. Once again, a very warm welcome to Mr. Chiranjeevalu and to all of you. Let's make this event an enlightening and member experience. Now, sir, the platform is all yours.
Thank Respected Chairperson of the Department, Chemical Engineering, Dr. Nikhil Kotorkar ji, and Vice Chairperson of the Department, Dr. Krishna Prasad ji, and Jayanarayanan ji, and my dear students, good evening. Today, I want to share a topic which is related to purely chemical engineering department, chemical engineers. This will help you to make your career opportunities the best way of getting the dream layer opportunities in future. Are you able to hear me, please? Hello?
Yes, sir, you're audible.
Can you able to hear me, please?
Yes, sir. You're audible, sir.
Oh, all right. So first of all, I congratulate all the students for selecting Vishwavidya Peetham for one of the top university in India. Got recently NIRF National Institutional Ranking Framework, 7th rank, a very prestigious rank. I congratulate all the students for and the department as well as the organization. Petroleum Refinery. You see, the Ministry of Petroleum and Natural Gas, Government of India, responsible for crude oil exploration, production, refining, distribution, marketing, import, export, conservation of petroleum, natural gas, and petroleum products. This completely taken care by Ministry of Petroleum and Natural Gas in the Government of India. There is a separate entity. They will take care of all these responsibilities. Petroleum sector is divided into two streams, namely upstream sector and downstream sector. Let us see what is upstream sector and downstream sector. Sector. Upstream sector identify oil and gas deposits, drill wells, recover crude oil and natural gas from the earth's crust. That is a separate entity which will take care of exploration and drill wells. The major players of upstream projects in India are Oil and Natural Gas Corporation ONGC, Reliance Industries Limited RIL, Oil India Limited OL, Larsen and Toubro Limited LNT, British Petroleum. These people will do this particularly upstream projects. What is crude oil? Crude oil is black in color, viscous material, will not freely flow. Crude oil is a mixture of volatile liquid hydrocarbon composed of 82 to 87% of carbon, 12 to 15% of hydrogen by weight. It also contains some impurities like sulfur and nitrogen. These impurities are unwanted material and will affect the final products also. So, initially, every refinery has to remove the sulfur content and nitrogen content from the crude oil while processing the finished products. Crude oils are said to be sweet or sour based on sulfur content. Sweet crudes will have sulfur up to 0.5% by weight or less. Sour crudes will have sulfur 1% up to 2.5%. Also will be there in sour crude oils. Important properties of crude oil. Important properties of crude oil: density, S and W, bottom sediments and water sulfur content, and salt content. Density is required to know the quantification of the crude oil. Convert the volume from volume to weight also. S and W, bottom sediments and water, it will not convert into hydrocarbon products. So we have to see that how much bottom sediments and water is present in the crude oil. Water sulfur is an impurity which has to be removed from the crude oil. Salt content, it will give the corrosion to the distillation column and will spoil the entire system. So we have to check what is the salt content in crude oil, and initially we have to remove the salt content from the crude oil before processing the crude oil in the column. Are aware of is defined as mass per unit volume. There is a standard test method for specific gravity or density of crude oil by using ASTM D1298, American Society Testing and Materials, ASTM. So why this slide is put here? Because engineer know how to do the density of crude oil, because some people will work on the offshore or onshore platform. Before releasing the crude oil, they should know the quality of crude oil. So standard test methods also they should aware of that. Whenever you do the density by using the cylinder, hydrometer and thermometer, will not give directly at 15 degrees centigrade. The world, take any country, all the crude oils or crude oil products be measured at 15 degrees only. In order to take 15 degrees centigrade, we have to measure the temperature and corresponding hydrometer density, and then you have to convert by using ASTM 53A table to 15 degrees centigrade. Then BSNW. This is one of the impurity. It will not convert into usable products or any hydrocarbon. Bottom sediments and water are impurities in crude oil. The standard test method for BSNW, ASTM D4007. When you see the ASTM D4007, that method shows that 1600 RPM centrifuge we have to use, and the crude oil is charged in the centrifuge tube and place the centrifuge and do at 1600 rpm for 10 minutes. Automatically the bottom sediments and water will be settled down at the cone of the tube. Then we can measure how much volume of water and sediments are present in the crude oil. Total sulfur. Total sulfur in crude oil is an impurity which will give impact on finished products. You are aware of that at present the sulfur content in the metropolitan cities in MS motor spirit or diesel is 10 ppm. So 10 ppm is very low comparatively. In 90s it was 1%. After that it become 0.5%, and after that it has come to 50 ppm. That is 404 or BS4 products. Some of the areas still BS4 is using. In metropolitan cities, BS6 has come into the force from 2020 April onwards. Total sulfur content is only 10 ppm is allowed in motor spirit or diesel, which is using as a fuel for the vehicles. Standard test method for ASTM D4294, that is energy dispersive X-ray fluorescence spectroscopy. This is very useful for all petroleum refineries or petrochemical industries, because here if you place the sample within 2 minutes you will get the sulfur content in that. Earlier people used to use bomb calorimeter, which takes 8 hours to 10 hours for one sulfur content. Salt content. Salt content, as I have already told you, salt is very dangerous when it is present in the crude oil. It will give the corrosion to the distillation column. Thereby, all the plates, metal plates will be corroded and collapse. It will be collapsed at one stage. So, salt content has to be measured. It should not be more than 3 ppm in oil. The standard test method is ASTM-D 3230. This is a what you call conductivity meter. Salt is present in the crude oil, it will show the conductivity. Correspondingly, we have to use one standard and calculate how much salt content is present in the crude oil. That is the what you call minimum important properties for the crude oil. Crude oil is the raw material for the refineries. So classification of crude oil is also important, and you should aware of this. Crude oils are classified based on API gravity, American Petroleum Institute gravity. There is an organization called American Petroleum Institute. They will decide what is the standards and other things related to crude oils and the finished product. Heavy crude oil, when the API gravity is 10 to 20, then it is said to be heavy crude oil. Medium crude oil, 22 to 25 API gravity. Light crude oil, greater than 25 API gravity. Why this is required? Required because we will come to know initially how much yield will come from the each crude. If heavy crude oil, that is what you call 10 to 20 API gravity, when it is present, then the crude oil will not give finished products more and more. It will give only up to 40% from the crude oil. The 60% will be residue. 60% will be residue. Then it will not be feasible, it will not be profitable to the organization or any refinery or whoever process the crude oil. Medium crude oils will have 22 to 25 API gravity, which will give 62 to 65% finished products directly. and the remaining will be asphalt or bitumen. Light crude oils will have greater than 25 API gravity, will have up to 95% finished products, which will give you what you call 95% finished products. This API gravity will be calculated based on the 141.5 by density or specific gravity at 15 degrees centigrade minus 131.5. This is a universal formula wherever you go. If you use this formula, then we will come to know the what is the API gravity of that particular crude oil. Major crude oil reserves in the world are Venezuela, Saudi Arabia, Iran, Iraq, Kuwait, United Arab Emirates, Russia, Libya, United States, Nigeria. India, we have oil assets at Rajasthan, Gujarat, Mumbai High, Krishna Godavari Basin, and Assam. Rajasthan Nile crude is available, and Gujarat, North Gujarat and South Gujarat crudes are available. This is taken care by the RIL. Rajasthan crude, Nile crude is by ONGC. Mumbai High is a major asset in India. Mumbai High. This is ONGC crude oil, which will have 0.2% sulfur. That's why it is a golden crude oil. It's a black gold. People used to call black gold. 0.2% is very, very difficult to get very low sulfur content in Mumbai high crude oil and will give 95% of the finished products from Mumbai high. Krishna Godavari basin, Rava crude is available. This is also taken care by ONGC. Assam crude is also there in India. The downstream projects. Let us go to our topic from this point of what you call presentation. What is downstream sector? Downstream sector, petroleum refineries use various petroleum products by fractional distillation from crude oil that consumers use every day. Example, liquefied petroleum gas, naphtha, water spirit, kerosene, aviation turbine fuel, high-speed diesel oil, and bitumen. These are the products from the crude oil. Fractional distillation is nothing but separation of the hydrocarbon components at a distinguished temperature. That means you can decide what temperature of the final boiling point. Accordingly, we can do that separation. That's why it is called fractional distillation. Generally, this LPG, it is not liquid petroleum gas, it is a liquefied petroleum gas. And aviation turbine fuel is one of the superior kerosene product. It is used for aircrafts. See the distillation and fractional distillation. The normal distillation. Distillation is the process of evaporation followed by condensation. Simple distillation, evaporation followed by condensation. Whereas fractional distillation, here you can see number of plates, the column. So separation of hydrocarbon mixture into its components for fractions. The typical diagram of petroleum refinery, you can see number of columns, number of heat exchangers, and surge drums, and cooling, what you call coolers and pumps. The configuration of the petroleum refinery is a common configuration. It is called typical configuration. Every refinery will have the same pattern. Here crude oil is inlet. What you call crude oil goes into the atmospheric distillation column. It is also called crude distillation column, crude distillation unit, CDU. CDU, crude distillation unit. Here fractionation takes place, and we will get from LPG to diesel. The top, the gases will come and condensed gas processing unit, and the gases will go to Merox treater. Why it has to go to Merox treater? Merox, mercaptans oxidation unit. Wherever Merox is there, there mercaptans will be removed. mercaptans and sulfur components, other sulfur components also will be removed by mercaptans treater. Then pure LPG or butanes will come out from the top. Then light naphtha. Light naphtha next the gases next to LPG, light naphtha. This will go to the hydrotreater. Light naphtha will have the final boiling point up to 100 degrees centigrade. So here the cutting temperature of light naphtha is 100 degrees centigrade. This will go to hydrotreater where hydrogen addition takes place, and then the sulfur, the form of hydrogen sulfide will come out, and it will go to the isomerization plant, and isomerate will form and will go to the gasoline pool. Gasoline is nothing but motor spirit or motor gasoline. In nomenclature, in normal usage, people used to call petrol, but chemical engineers, I suggest we should not call it as petrol. Petra means rock, oleum means oil, petroleum means rock oil. So it is not rock oil, it is a motor spirit or gasoline. Motor gasoline. Next to light naphtha, heavy naphtha will come. This heavy naphtha will go to the hydrotreater. Again, hydrogen addition will take place, and the hydrogen sulfide will be removed, and then it will go to the catalytic cracker or reformer. It is called reformer, catalytic cracking and reforming. There, all normal paraffins will become isoparaffins, normal paraffins, isoparaffins, and then this will go to the again what you call motor spirit or motor gasoline pool. Next to that, jet fuel or kerosene. If kerosene demand is there, generally kerosene will take will takes out. Otherwise, jet fuel, it will be converted into jet fuel. That is called aviation turbine fuel. Aviation turbine fuel nowadays it is having more demand in the market. Kerosene demand is not there at present because even people in domestic purpose, people are not using kerosene everywhere. LPG is only using for cooking purpose. So kerosene demand except railway. There are some signals still people are using kerosene for railway signals, railway gates. Jet fuel is having more demand, aviation turbine fuel, but mercaptan sulfur is one of the major constraint in the jet fuel that has to be removed from the jet fuel by using peroxytreater. This mercaptan sulfurs will be removed by mercaptan's oxidation. Here, mercaptan's oxidation takes place, thereby sulfur free, mercaptan's free kerosene or aviation turbine fuel will come out from that column. And diesel sulfur content will be removed by hydrotreater, and sulfur free diesel will come out from the column. Then finally atmospheric gas oil that will go to the vacuum distillation. Here vacuum distillation will maintain from 22 to 50 mm pressure. A vacuum will be maintained from 22 to 50 mm pressure. Thereby vacuum residue, vacuum gas oil will come out. This vacuum gas oil is very useful and will give very pure products. Sulfur free products will give when you put this vacuum gas oil into hydrocracking unit. When you put it into hydrocracking unit, there the catalyst will be there, hydrogen addition will take place, thereby this vacuum gas oil will be cracked and will give LPG, kerosene and diesel. Finally, the vacuum residue will come from the bottom and it is called asphalt. Asphalt or bitumen, general terminology or nomenclature is tar. It is using for paving the roads. Asphalt, again treatment will take place in bitumen unit to make the penetration high, softening point low. That way they will make this bitumen. Operating units in refinery. What are the operating units in refinery? What is your what you call your placements in refineries? where the chemical engineers taking roles in this particular units. Crude distillation unit. Crude distillation unit is run by the chemical engineers. A vacuum distillation unit is purely run by chemical engineers. Bitumen unit operate. It is all units comes under operations. Bitumen unit also what you call the chemical engineers area only. Mercaptan's oxidation unit, hydrocracker unit, catalytic cracking and reforming unit for making the MSR motor gasoline, fluid catalytic cracking unit for making the what you call motor gasoline, diesel hydrotreating unit, power plant, hydrogen plant, sulfur recovery unit, coker unit, oil movement and supplies, wastewater treatment plant. These are the units in the refinery, except power plant. Except power plant. All these units are run by chemical engineers. All these operations be taken care by chemical engineers, except power plant. In this power plant, mechanical engineers will be there because turbines and steam generators are the major equipment because water will go and it will become steam. The steam will go to the turbine and turbine will rotate, thereby power generation takes place. This unit, except this unit, all the units are run by chemical engineers. What is CDU? We have seen that there are many columns. Crude distillation unit is the heart of the refinery. Crude oil distillation unit is the first processing unit in petroleum refinery. Any petroleum refinery, if you take, crude distillation unit will be there. CDU distills the incoming crude oil into various fractions, and each fraction is processed further in other units to meet the standard specifications laid down by Bureau of Indian Standards. Oil distillation unit will give the products, but the products will not meet the market requirements or the specifications as per the Indian specifications. As per IS specifications, it will not meet. That's why the fractions has to put into other units to remove the impurities and make the standard specifications. VDU. Next unit, vacuum distillation unit. Vacuum distillation unit helps to produce petroleum products out of the heavier oil left over from crude distillation unit. Previous unit, whatever left over, will come to the vacuum distillation unit. Vacuum distillation unit. Here, I have already told you 22 to 50 mm pressure will be maintained in vacuum distillation unit. Because of that vacuum, at low temperature, at high vacuum, whatever the residue will give the vacuum gas oil. Vacuum distillation unit helps to produce petroleum products out of the heavier oil left over from the crude distillation unit. I think it is very clear to you. Next, bitumen unit, coker unit, Mirax unit. These three units. Bitumen unit, what it does? Converts the vacuum residue, whatever the residue comes out at the bottom from the vacuum distillation unit will go to the bitumen unit to make the bitumen for paving the roads. It converts the vacuum residue into bitumen by air blowing because it will have some softness. Softness has to be removed by blowing a hot air. When you blow hot air, the lighter ends will go out from the vacuum residue. It will become brittle or hard. Coker unit. How this coker unit has come in between? Coker unit now, India, cement demand is less because whenever the road pavement is there, then only the bitumen demand will be there. Road making is not there, then bitumen demand will not be there. Then where the bitumen stock will be preserved in the refineries because there are certain tanks. Each tank may have some 30,000 liters capacity. If you have 10 tanks, then Only 2 to 3 days you can preserve this bitumen, whatever produced from the, depending on the, again, capacity of the refinery. What to do when bitumen is full in the bitumen tanks? So that's why the coker unit has come into the picture. It is having its own value, is a value added product, as well as there is no any problem for preserving in the tankage form. Here the tankage form is not required. Directly whatever residue comes from the VDU will go directly to the coker unit. Coke will be formed. Coke will be produced from coker unit. This is having very demand in India at present for railway as well as cement industries and kilns, iron and metal industries. Coke is required. It converts the vacuum residue into low molecular weight hydrocarbon gases, naphtha, gas oil, and petroleum coke. What it does, coker unit, it converts the vacuum residue to lower molecular weight hydrocarbon gases, naphtha, gas oil, and petroleum coke. Petroleum coke, when we produce, then we will get some low molecular weight hydrocarbon gases like some what you call sour LPG, which will have more hydrogen sulfide, sour naphtha, which will have more hydrogen sulfide, and gas oil. This is diesel. Gas oil is nothing but diesel. Then these three products will be further purified in different units, and petroleum coke is the main product from the coker unit. Perox unit sweetens the petroleum products like purified petroleum gas, naphtha, and aviation turbine fuel by oxidizing the mercaptan sulfur. Mercaptan sulfur will be oxidized here, and sulfur free or mercaptans free products will come out from the Perox unit. CR, FCC, DHDT units. Catalytic CCR, catalytic cracking and reforming unit. That is called CCR in simple form. Catalytic cracking and reforming unit converts the naphtha low octane fraction into high octane product called reformate. What it does, it will convert all paraffins to isoparaffins, all paraffins into aromatics. Some aromatics, aromaticity will increase. Because of aromaticity, octane number will increase. Low octane fraction into higher octane product like reforming. With catalytic cracking and reforming. This is clear to you because aromatics increase by catalytic cracking and reforming. FCC. Fluid catalytic cracking unit converts heavier fractions vacuum gas oil, which will come from vacuum distillation unit. Fluid catalytic cracking unit converts heavier fractions into lighter products in the presence of catalyst and heat. Gasoline is the main product from FCC. Gasoline is nothing but motor spirit or motor gasoline or in normal nomenclature, general nomenclature, petrol. DHDT, diesel hydro desulfurization unit. Diesel hydro desulfurization unit improves the diesel quality by removing sulfur over catalyst bed in the presence of hydrogen. Here hydrogen addition will take place. Because of hydrogen addition, what it does, hydrogen will go and sulfur, because of temperature, sulfur will become sulfur dioxide. This hydrogen will react with sulfur dioxide and hydrogen sulfide will form and it will be removed from the column. Hydrocracking unit, hydrogen plant, power plant. Hydrocracking unit, it breaks down the heavy petroleum fractions, vacuum gas oil into lighter fractions like LPG, naphtha, kerosene, and diesel in the presence of hydrogen and catalyst. This hydrocracking unit. This has come very what you call recently into the all the refineries for establishing hydrocracking unit. The catalyst is very costly, multi crores rupees refinery has to spend for catalyst to remove what you call to break the heavy petroleum fractions into lighter fractions, heavy molecules into lighter molecules. Like LPG, naphtha, kerosene, and diesel will be formed. These products will not have any sulfur. LPG will be zero sulfur. Naphtha will have 5 ppm, 5 parts per million. Part per million is nothing but 0.0001%. So naphtha will have 5 ppm, kerosene and diesel will have maximum 5 to 8 ppm. So whatever the products comes out from hydrocracking unit, the diesel can sell directly into the market as Euro 6 product, because at present Euro 6 diesel specification is 10 ppm max. Presence of hydrogen and catalyst, hydrogen plant. Why hydrogen plant is required? Hydrogen is required for hydrocracking unit as well as DHDT and some other units also. Hydrogen is generated from naphtha cracking. Naphtha cracking in steam reformer. So it will generate hydrogen. So power plant. Power is generated by running steam turbines using fuel oil as a fuel for boilers to produce steam from DM plant. I have already told you, DM water will go to the boiler and it will generate the steam, and steam will go to the turbine and it will rotate at higher speed and power will be generated. Next units, OMS and ATP. What is oil moment and supplies? This plays very important role in refinery. OMS, oil moment and supplies, receives the raw material. It receives the raw material crude oil from various locations, from the ships, finished products. Receive the crude oil from the ships, finished products from the various operating units. It also receives the finished product from various operating units and store safely in storage tanks. There are so many storage tanks will be there in OMS area. So it will store the products, finished products into storage tank. The unit supplies the finished products to all consumers through pipeline, ships, and trucks. And treatment plant. This is a very major area in any organization of the whenever there is an effluent is formed or unwanted gases, unwanted liquids, what you call generated. Effluent treatment plant will be looked after by very keenly, because there are so many statutory bodies will observe, like pollution control board, central pollution control board, or state pollution control board. Effluent treatment plant treats the effluents coming from various operating units and discharge the treated water into the sea once the effluent meets the CPCB, Central Pollution Control Board norms. Because there are some Central Pollution Control Board norms like pH and COD, chemical oxidant demand, BOD, biological oxidant demand. When you put this effluent into the seawater, then aquatic animals should not die. That's why the more responsible people, the ETP, are chemical engineers. So they should be very careful about the each and every minute in the effluent treatment plant whenever they do the discharge, treated water discharge into the sea. Up to there, they are all operating units and related to all chemical engineers. And then here, there are some other departments. Here also, chemical engineers participation or their roles are there. I will tell you this. What is that? Quality control and R&D. And R&D. Quality control and R&D, normally MSc, PhDs will work. Nowadays, there are many companies, they are hiring even chemical engineers in R&D division. These people, what they do, they will take the crude oil quality or crude oil properties and intermediate product quality and finished product quality also. And they will do some R&D division separate will be there, R&D division. There they will do some research work, some research projects also. Technical services. This is purely again chemical engineers area. Technical services. What they do? Technical services. The chemical engineer will come morning, generally in general shift, and then they will take the all the what you call flow charts and data, the parameters, and the product consistency. They will take the product quality from QC and they will analyze any bottlenecks are there, any designing problems are there, they will identify, they will resolve that issues by what you call by changing the design or the changing the parameters. They will give the instructions to the operations to change the parameters also. Fire and safety for safety purpose, health, safety and environment. Again, this area is meant for the chemical engineers only. They have to see what are the effluents are generating, what are the effluents are what you call routing to outside, and how much air pollution is producing, and they will monitor even in the what you call stacks also. Mechanical maintenance is purely by mechanical maintenance people, inspection and designing. They will do this mechanical people, this inspection and designing for tankage project. Instrumentation, separate instrumentation people will be there for solenoid valves operation, air inlet, air outlet, and other operating units performance. Electrical is general electrical works, civil for construction works as well as the bottom platforms for the tankage and other areas they will work. HR department for recruiting the people and what you call not only for selection, deciding wages and salaries, and they will see the attendance also, leave pattern. These things they will monitor. Finance people they will pay money for the crude oil and they will take the money from the customers whoever take the finished products. Materials department, a separate department will be there. Again here, some chemical engineers will be there because whatever indents comes from the various operating units, they have to verify the requirement and then they have to call the vendors and negotiate. Negotiate in the sense specifications, not money point. They will negotiate with vendors the specifications and what else required because these people when they have the knowledge background knowledge of chemical engineering they will be able to negotiate with the vendors. That's why some people will work in materials department also. Marketing here also some people will be there. Marketing, not only marketing, whenever there is a problem of the product, this marketing chemical engineer has to resolve the marketing issues in the technical point of view. Yes, this is what you call a department for systems department, internal system department, documentation for preserving the all the P&I diagrams and the unit configurations and other things. When you come to the refinery products. Refinery products are liquefied petroleum gas LPG, light naphtha, heavy naphtha. Light naphtha will have 100 degrees centigrade. LPG will be taken out up to 30 degrees centigrade, and from 30 degrees to 100 degrees, the product whatever distillate comes out from the crude oil is called light naphtha. From 100 degrees to 150 degrees called heavy naphtha. The 150 degrees to 250 degrees called motor gasoline. Motor gasoline, no, kerosene. So how this motor gasoline has come? This naphtha will be converted into motor gasoline. This naphtha will be converted into motor gasoline. Motor gasoline will not give directly as a distillate from the column. It will give only light naphtha and heavy naphtha. From this naphtha, motor gasoline will be produced by putting in the CCR unit. Here, aromaticity will increase. Because of that, this is working as a motor gasoline. What is the difference between naphtha and gasoline? Naphtha will have octane number 60 or 62 max, whereas motor gasoline will have 91 octane number for usage purpose. As per Indian standards, motor gasoline should have octane number 91 minimum. Kerosene will have 150 to 250 degrees centigrade. This is another form of aviation turbine fuel. Aviation turbine fuel, there is no separate product. Kerosene only aviation turbine fuel when mercaptans are removed from the kerosene. Mercaptans are removed from the kerosene. This is very useful product, and the cost point of view also, this is having more demand. Next product is diesel, then vacuum gas oil, fuel oil. Fuel oil is for the purpose of boilers. Bitumen for paving the roads. The sulfur is the byproduct. When we take the crude oil, sulfur will be removed from the crude oil. It is a byproduct from the crude oil, which will go to the sulfuric acid plants. Sulfur is the raw material for sulfuric acid plants. If you see the boiling range of petroleum products, because you should aware of the this what you call boiling ranges also. LPG up to 15 degrees centigrade, the maximum time what you call 30 traces will go, and light naphtha up to 100 degrees centigrade, heavy naphtha up to 150 degrees centigrade, kerosene or ATF 50 degrees centigrade. That means 150 to 250, whatever comes out from the column is kerosene. From 100 to 150, whatever comes out, that is heavy naphtha. HSD up to 375, from 250 to 375 degrees, whatever cut comes out from the crude oil is called diesel. Up from 375 to 550, the material is called vacuum gas oil. Vacuum gas oil. This is the what you call feedstock to the hydrocracking unit. This will not come into the market directly, and nobody will use this VGO for any purpose for as a fuel. So it has to be cracked in the hydrocracking unit. Again further LPG, kerosene, naphtha and diesel will come out. Converted completely, it will be converted into finished products. And bitumen above 550 degrees centigrade, bitumen product which is used for paving the roads. What is the typical breakup of the finished products? If you take the crude oil, what is the typical breakup? Any crude oil, this is the 2% maximum will be there. LPG, this is by weight. If you take 1 kg, then only 2% LPG will be there. The 12% of naphtha, it is together, light naphtha and heavy naphtha together, 12%, and kerosene or ATF, 14%, diesel 25%, and VGO. This will be again a feedstock to the hydrocracking unit. I told you already. 25% VGO and 22% bitumen, which is using for paving the roads. Again, this configuration will change based on API gravity. If you take more heavy crude, 10 to 20 API gravity, this LPG will not be there. LPG will not be there. What you call naphtha will not be there. It starts from kerosene. The kerosene will be hardly 5%, and the diesel will be 10 to 15%, and this will be there 25%, and remaining will be bitumen only. That's why initially I told that it will not give more than 40% yield. This is clear to you? A typical breakup of the finished products. LPG storage facility. You might be seen that there are spherical, what you call storage tanks for LPG, not cylindrical. Anybody can tell why spherical is required for LPG? Able to hear my voice, please? Hello?
Yes, sir. We can
Can
hear.
you able?
Yes,
Anybody,
sir. We can hear.
any one of the student can give the answer for that? Why spherical spheres are required for LPG storage? Why not cylindrical tankage form? Because I will tell you, pressure will be maintained uniformly in the spherical form, whereas cylindrical storage tanks, uniform pressure will not be there at any point of what you call storage facility. That's why to maintain the uniform pressure, storage tanks for LPG is in spherical form. Here, next, the other petroleum products from naphtha to MS motor spirit or bitumen or kerosene, they are all cylindrical form. This is all cylindrical form only, not in spherical form. Indian standards for petroleum products. Indian standards. What are the Indian standards for petroleum products? LPG, liquefied petroleum gas. The Bureau of Indian Standards is 4576. The standards, every chemical engineer, whenever they go to refinery or petrochemical or petroleum industry, they should be aware of all these standards because they should have a copy of that. Because what are the specifications for LPG? How much what you call sulfur is allowed? What is the volatility property of LPG? And this what you call limits will be there in that specification. IS 4576 meant for LPG. Motor gasoline, which we are using for two-wheeler and four-wheeler as a petrol, that is IS 2796. What is the octane number, minimum octane number? How much sulfur is allowed? And what is the knock intensity? Sound pollution. Knock intensity is nothing but sound pollution. And kerosene, what is the specification? IS 1459. Aviation turbine fuel, IS 1571. High speed diesel, IS 1460. Fuel oil, IS 1593. Bitumen, IS 73. These are the Indian standards. If any other standards required by other countries, they will give their own standards and specifications. That is customer what you call designed specifications. That also should be produced by refinery. They will give their own specifications. But Indian standards, these are the standards. You should be aware of that. And every parameter you should know what is the limit for each parameter also. Here, important parameters of petroleum products. What are the important parameters of petroleum products? Density. It is very important to know the what you call quantification for the quantification purpose. Density is defined as mass per unit volume, grams per cc or kilograms per liter unit for density. Distillation. Distillation is the process of separation of components from a liquid mixture by evaporation followed by condensation. Percentage volume. Distillation. Flash point. The lowest temperature at which the vapors of a volatile material ready to ignite if given an ignition source. That means if you give any a small source, ignition source, it will give the flash. That is the lowest temperature. The temperature is known as flash point. It is required for kerosene and diesel and aviation turbine fuel also. Aviation turbine fuel 38 degrees centigrade, what you call maximum allowed or allowed what you call minimum allowed 38 degrees centigrade. If it is below 38 degrees centigrade aviation turbine fuel, it will not be taken into flight. If 35 degrees centigrade diesel is the minimum for flash point, if it is less than 35 means 34 degrees centigrade diesel is not allowed into the market. Kerosene also 35. The flash point is very important for safety point of view. Safety point of view when the transportation takes place from one place to other place of this fuel. Viscosity. Viscosity of a liquid substance is the resistance offered per unit area in centistrokes. Viscosity is measured in centistrokes. Viscosity of a liquid substance is the resistance offered per unit area is viscosity, centistrokes. Calorific value, heat produced by complete combustion of a unit mass of substance. Calories per gram measured in calories per gram, calorific value. These are all definitions you may be aware of that. You might have studied in intermediate and below that. Calorific value, heat produced by complete combustion. For example, if you take 1 gram of water to rise by 1 degree of centigrade, that is 1 calorie. Color. Color of the product denotes the degree of refining process. The product is colorless, then it is said to be what you call refining process is good. The about color is used or ASTM color comparators are available in the market. We have to check with this color comparator the product with the color comparator. Then we'll come to know how much color is there for the product. 4 point. The minimum temperature at which the liquid hydrocarbon ready to freeze, that is in degrees centigrade. The minimum temperature at which the liquid hydrocarbon ready to freeze. CFPP, cold filter plugging point. CFPP means cold filter plugging point. This is required for highly elevated places like Himalayas and hill areas. CFPP is required for diesel. The lowest temperature at which a given volume of diesel fuel passes through a standard disk filtration, because whenever the fuel goes into the combustion chamber, there is a filter unit in every motor vehicle. So fuel will not pass through the filtration disk at the lowest temperature. That means when it is cooled to certain temperature, it will be the filtration unit will be clogged. The filtration will not take place, and the fuel will not pass into the combustion chamber. That's why CFPP is required. For the temperature, CFPP temperature. Volatility. What they do when they know the lowest temperature CFPP, then they will put the heater to heat the what you call fuel before passing into the combustion chamber. Volatility. Evaporation character of a hydrocarbon liquid is called volatility. This is a property for LPG. LPG at room temperature has to come out as a gas. And they fill the gas only, they will put under the pressure. That's why it is a liquefied petroleum gas. Actually it is a gas, but it is in the form of liquid because of pressurized in the cylinder. When it comes out again, it has to come as a gas. If the volatility is not okay, means if you see the LPG, it will have purely butane gas. Butane Pentane is present in LPG. What will happen when pentane is there in the butane? Then the volatility will fail. That means the gaseous form will not come out from this cylinder. The cylinder will have the liquid, but the gas will not come out. That says that it is a half spec product. There is some contamination of propane to butane. Acidity or acid number. Milligrams of potassium hydroxide required per 100 grams of sample. Milligrams of KOH means potassium hydroxide required for 100 grams of sample. The number is acid number or acidity. Every product we have to monitor the acid number. Otherwise, the storage tanks of fuel will get corroded and holes will form and the fuel will be out at one stage. Corrosion. Corrosiveness property of fuel reacts with metals and form metal oxides or metal sulfides. Tarnish is measured with ASTM color. Whether the sulfur dioxide, what you call corrosion, takes place or not, that we can monitor with the tarnish. Tarnish means black stains on the surface of the pipelines. Important parameters of petroleum products. Sulfur. Sulfur is the main impurity in petroleum products and it causes to pollute the atmosphere. Sulfur is present in the motor gasoline or diesel. It will come as sulfur dioxide from the silencer, then it will pollute the atmosphere. So, as minimum as possible, as per the specifications, sulfur has to be maintained. Sulfur is the main impurity in petroleum products and it causes to pollute the atmosphere. That's why we have to monitor how much sulfur is present in the fuel. Aromatics, it is also dangerous. Benzene. Benzene is an aromatic compound. Benzene is there, it will give the atmosphere spoil an important parameter MS, motor spirit, and toxic to the atmosphere. Benzene is a toxic component, hazardous component. RON, it is a measure of knock resistance behavior. Sound knock behavior means the whenever the engine runs, what is the knock intensity that we can measure what you call by knowing the RON. If RON is less, then it will give more knock sound. Anti-knocking property of a fuel is nothing but RON. Lubricity. The capacity of a fuel for reducing the friction is known as lubricity. Why the lubricity is required? Wear and tear will take place otherwise. The diesel is having low lubricity, then the high friction will generate and then the wear and tear will take place. That's why lubricity of the fuel has to be monitored. Capacity of fuel for reducing the friction is known as lubricity. The property is measured for diesel fuel. Smoke point, smoke tendency. Fuel tendency to generate smoke when it is burned. It is the parameter for kerosene and AVM and ATF also. Freezing point, the minimum temperature at which the fuel ready to crystallize. This is very important parameter for aviation turbine fuel. When the flight goes at a higher elevations above 5 kilometers, generally all the flights will run above 5 kilometers from the ground. When it goes to that what you call higher elevations, then the fuel should not be crystallized. If it is crystallized, then the fuel will not flow into the combustion chamber. Then the flight will be collapsed. That's why freezing point minimum minus 47 for aviation turbine fuel. That is the important specification for ATF. Penetration. Distance of standard needle penetrates into bituminous sample under standard conditions. This is required for bitumen sample. You might have seen in the summer or winter or some other season. In summer season, the bitumen flows edges of the road because of softening point out of spec product. Otherwise, the stones which are mixed in the bitumen for paving the road, the stones will come out. Bitumen will be there, but the stones will come out and there will not be any resistance on the road also. That is because of penetration. Softening point, the minimum temperature at which the bituminous sample cannot bear the standard weight. I have already told now, in the summer season, because of low softening point, that will become like ice cream and it will flow to the edges of the road. From here onwards, you have to concentrate little bit for your career opportunities. India's current crude oil refining capacity as of today 149.9 million metric tons. India's current crude oil refining capacity is total refineries capacity is 249.9 million metric tons per annum and the domestic consumption of petroleum products is 213.7 million metric tons per annum. The delta between 249.9 to 213.7, the delta of this products goes to the other countries like Sri Lanka because Sri Lankan people are importing our products from India and Mauritius people completely they are taking Indian refineries products for their what you call vehicular purpose and other purposes also fuel oil and the aviation turbine fuel, what you call fuel oil, aviation turbine fuel, and some other products like naphtha. Also, they are importing Mauritius countries. You are aware of that Indian Oil Corporation, IOCL, Indian Oil Corporation Limited. They have 9 refineries across the country. The Paradeep Refinery, Paradeep in Odisha state, have 15 million metric tons per annum crude processing capacity. These are all crude processing capacities. Paradeep Refinery, 100%. If they process 15 million metric tons per annum, they will process the crude oil. Panipat Refinery, Panipat, Haryana, 15 million metric tons per annum. Gujarat Refinery, Vadodara, Gujarat, 13.7 million metric tons per annum. Haldia Refinery, Haldia, West Bengal, 7.5 million metric tons per annum. Barauni Refinery, Barauni, Bihar, million metric tons per annum. Bongaigaon Refinery, Bongaigaon, Assam, 2.35 million metric tons per annum. Gauhati Refinery, Gauhati, Assam, 1 million metric tons per annum. Digboy Refinery, Digboy, Assam, 0.65 million metric tons per annum. Mathura Refinery, Uttar Pradesh, 8 million metric tons per annum. These are all refineries belongs to Indian Oil Corporation across the country. You have the opportunities in any one of the refinery. If you try for your career, because why I put these slides, because you should know what are the configuration, what is the network, refineries network in India. All these Indian Oil Corporation refineries. Next, HPCL, Hindustan Petroleum Corporation, is having 2 refineries. One is at Mumbai, that is called Mumbai Refinery, Mumbai, Maharashtra, 7.5 million metric tons per annum crude oil processing capacity. Vishaka Refinery, Visakhapatnam, Andhra Pradesh, 8.3 million metric tons per annum. These 2 refineries belongs to Hindustan Petroleum Corporation. BPCL, Bharat Petroleum Corporation Limited. This Bharat Petroleum Corporation Limited is having 2 refineries. One is Kochi Refinery, Kochi, Kerala, 15.5 million metric tons per annum. Mumbai Refinery in Mumbai, Maharashtra, 12 million metric tons per annum. ONGC is having 2 refineries. One is Mangalore Refinery and Petrochemical Limited, Bangalore, Karnataka, 15 million metric tons per annum. Will be enhanced further to 25 million metric tons per annum in 5 years duration. Tatipaga Refinery. This is a small refinery because crude oil is producing from Krishna Godavari basin, where they put a small plant for recovery of diesel and kerosene from the whatever crude oil. While taking out the crude oil, whatever comes out, that vapors and all, they will process in this unit. That is 0.066 million metric tons per annum. CPCL, Chennai Petroleum Corporation, also belongs to Indian Oil Corporation, a part of that. CPCL, Chennai Petroleum Corporation Limited, Manali Refinery, Chennai, Tamil Nadu, is having 10.5 million metric tons per annum. And one more refinery is there in near Chennai, Nagapattinam Refinery. Nagapattinam Refinery, Nagapattinam, Tamil Nadu, 1 million metric ton per annum. These 2 refineries belongs to Chennai Petroleum Corporation Limited. Numaligarh Refinery, Numaligarh, Assam. This belongs to BPCL, Oil India, Assam government. These 3 people together, they put a refinery. Bharat Petroleum Corporation, Oil India, Assam government together, they put one refinery. That is 3 million metric tons per annum in Numaligarh in Assam. All these refineries belongs to Government of India. Up to here, whatever I have told you, all the refineries, Indian Oil Corporation, or Indian Oil Corporation, or HPCL, or BPCL, or ONGC, CPCL, NRL. All these refineries belongs to Government of India. And the private refineries and joint venture firms. Joint venture firms. In India, there are 2 joint venture companies. These 2 things have come very recently into the, what you call, recently commissioned, and they are running now. Bharat Woman Refineries Limited. Bharat Woman Refineries Limited, Bina Refinery, Bharat Woman Refineries Limited, Bina in Madhya Pradesh. 7.8 million metric tons per annum. This is already commissioned and running now. HMEL, Guru Gobind Singh Refinery, HPCL and Metal Energy Limited. These two people together, HPCL and Metal Energy together, they put one refinery in Batinda, Punjab. 7.3 million metric tons per annum crude oil processing capacity of HMEL. And two private refineries in India. One is RIL, Reliance Industries Limited, Jamnagar, Gujarat. 68.2 million metric tons per annum capacity. Very huge refinery. 68.2 million metric tons per annum crude oil processing capacity by Reliance Industries. Here only in Gujarat, one more private refinery is there, SR Oil. In Vadinar, Gujarat, 20 million metric tons per annum. These two are belongs to private organization. These two are joint venture firms. These are the total refineries configuration in India. Career opportunities for chemical engineers. What are the career opportunities for you? Have the many people when they join in chemical engineering because I have given the presentations to IIT Hyderabad, Indian Institute of Technology Hyderabad, Vellore Institute of Technology VIT Vellore, NIT Andhra Pradesh for 2 times, National Institute of Technology, and I gave RVR and JC Engineering College Guntur for twice. JNTU, Jawaharlal Nehru Technology University, Kakinada, Canada, Chaitanya Bharati, Science and Technology, Hyderabad, then TPRIET, Coimbatore, TPRIET, then Aditya Engineering College. Like this, so many what you call MGR, Dr. MGR University, Chennai. HCL Technologies, Shivanadar is having one SSN University in Chennai, and Savita Engineering College in Chennai. SV is Sri Venkateswara Engineering College in Chennai. These all these SRM University, SRM University in Chennai. All these areas I have put my presentations physically, classroom sessions, not online session. A few I have done in online also. But wherever I go, all these chemical engineers only, all the chemical engineers, whatever I have told you, all the universities, chemical engineering students, I have given this um, presentations. I have observed that most of the chemical engineers, after joining, disappointedness regarding job opportunities. I want to tell you very clearly, you have a lot of scope, provided you should be strong in the basics of your chemical engineering. If you are very strong in basics, I am sure that definitely you will get the opportunities in the cream layer of industries, government industries, central government industries you will get. That's why I'm telling that this is do not discourage or do not think that the chemical engineering having a very good opportunity for getting the opportunities, wide opportunities are available. Now you see that there are chemical industries, hydrochloric acid plants, sulfuric acid plants, sulfur plants, all comes under chemical industries, petroleum sector. Now whatever I have discussed, petroleum sector, refineries. Petroleum, not only refineries, exploration, drilling, all these things comes under petroleum sector. There, chemical engineers only required. Mining, chemical industries, biotechnology, textile industries, nuclear power plants, pharmaceutical industries, metal industries like steel plant, And so many chemical engineers are there in steel plant, paper and pulp industries, polymer industries, fertilizer plants, food and beverages, R&D labs, finally educational institutions are making the students, for giving the lectures for the chemical engineers also. Okay. How many opportunities have? Some of the things I have put: chemical industries, petroleum sector, mining, petrochemical, biotechnology, textile industries, nuclear power plants, pharmaceutical industries, metal industries, paper and pulp industries, polymer industries, fertilizer plants, food and beverages. There also chemical engineers are required, whether it is food grade or not food grade. Beverages, R&D labs. R&D labs at present, every R&D lab is hiring chemical engineers for doing the projects. Educational institutions. One more thing is there. Pollution control boards that I have not put here. Pollution control boards, chemical engineers only will work to take the samples and analyze and give the what you call whether it is meeting or not. Competency level, what you should have, get the job, what you should have. If you want to get a good job, have a strong technical skills. The strong technical skills, how it will come? You are strong in the subject. Initially, I have told beginning at the beginning, I told that you should be capable. Give any information about the subject. Then only you will be very strong in technical skills. Strong in technical skills. Teamwork, team building. I am doing my job. So I have done my job. That is not enough. You should work with the team. Then only your project will be completed. Teamwork, team building. Should not be alone at one place and then should not think that I can do it, I will do it. No, not like that. You have to work in a team. Problem solving ability. You should have the problem solving ability. How not only thinking how this problem has come, you should have the solving ability. Leadership qualities, analytical skills, communication skills. These are the competency level is required for chemical engineer. ISO certification also you should be aware of that. Chemical engineer should know ISO certification. Why ISO certification? Nowadays it is a recognition. It's a recognition. Now if you see, I told you NIRF has given the certification to Amrita Vishwavidya Peetham, the seventh rank in India. How they got? Because their facilities, their workmanship, they have the strong faculty members in their organization, and their facilities are good, and the what you call making the students in such a way that the students getting good opportunities. All these parameters they have considered and they gave the rank. Seventh rank is not, it will not come just like that in NIRF. Got it. So like that ISO certification will give the recognition for any organization. What is ISO? International Organization for Standardization. ISO is an independent body that provides the standards for organizations. When you have the ISO certification, people will purchase the product because they will take it granted that the product is up to the mark. That's why ISO standard, every organization is acquiring, every organization is taking ISO certification from the standard body. The standard includes the quality, safety, and efficiency of the products and processes. What is the ISO standard? The ISO standard includes the quality, safety, and efficiency of the products and processes. When you follow the ISO, you will have the quality products. You will have the safety of the plant, safety of the people, and efficiency of the product and processes. ISO certification is a mark of quality and credibility for organization. That's why ISO certification, every chemical engineer should aware of that, how to get the ISO certification by what you call producing the documentation part. Documentation part you only have to do tomorrow. Any organization. ISO certification is a mark of quality and credibility for organization. ISO 9001 standard stands for one particular point. 9001, 2015 specification, ISO 9001 stands for Quality Management System. It is defined as a collection of business processes that focus on meeting customer requirements on a consistent basis. This is the 9001 specifications. Because quality purpose, you have to get ISO 9001. For environmental purpose, for 14001 is required. ISO 14001. ISO 14001 stands for Environmental Management System. This is also required for organization. EMS helps an organization to address its regulatory requirements in a systematic and cost effectiveness manner. EMS helps to reduce risk of non-compliance and improves health and safety of employees and public. What you call 14001 is also required for processing industries. There, so much pollutants will form. Whether it is a water pollutant or a air pollutant or sound pollutant. So, if you have the 14001 certification for your organization, that means it is meeting the sound pollution, meeting the water pollution, meeting the air pollution also. In such a way, the standards will be maintained. So there, I have discussed about the petroleum. Now, petrochemicals. Just a minute. Petrochemicals. Hello. Now, let me go to the petrochemicals. Petrochemicals are the chemical products obtained from petroleum by a refining process. So, in petrochemicals, any petrochemical industry, if you see that naphtha or butane or pentane or some other petroleum products, they will take as feedstock. Petrochemicals are of mainly types: olefins based petrochemicals, aromatics based petrochemicals. Olefins based petrochemicals are ethylene, propylene. These two is produced from olefins from the petroleum products. Aromatics: benzene, toluene, and xylene isomers. Xylene isomers means metaxylene, paraxylene, orthoxylene are produced. This xylene is the raw material for paint industries. Paint industry, the main product xylene, they will put the dye, color dye into xylene, they will produce the paints. Olefins and aromatics are the feedstocks for the petrochemical industry to produce. Olefins and aromatics are the feedstocks for the petrochemical industries to produce solvents, detergents, adhesives, polymers, resins, fibers, lubricants, and gels. All these products are produced from the olefins and aromatics based. See here, the chart will show you that complete clear picture. This is the oil and gas. Oil and gas means petroleum oil or petroleum gas. It will give butane. Butane, naphtha. I have already told in the beginning, naphtha is one of the products from the crude oil. Butane, naphtha, condensate. These are the feedstocks. Natural gas, propane, ethane. From this again, if you see that basic chemicals, here basic chemicals are forming from these feedstocks. Propylene, ethylene, butylene, ammonia, butadiene, methanol, aromatics. Aromatics means benzene, xylene are produced from these feedstocks. From here, some basic chemicals, again derivatives will form. Chemical intermediates are derivatives. Here you see styrene, cloth industries, cloth manufacturing. Ethylene glycol, isobutylene, acrylonitrile, glycerin, and others. From intermediates or derivatives, final products will be formed. Industrial chemicals, paints and coatings, synthetic rubber, explosives, resins, foams, dyes, adhesives, plastics, synthetic fibers, soaps and detergents. Soaps and detergents also petrochemical industry. What you call petrochemical, from petrochemicals only. How many products are there? Final products. Industrial chemicals, paints and coatings, synthetic rubber, explosives, resins, foams, dyes, adhesives, plastics, synthetic fibers, soaps and detergents. From there, again, end users. Final products, who will use? Final product, who will use? End users. Clothing, cloth manufacturers, packaging, paper industries, appliances, electrical or some other appliances, vehicles, machinery, electronics, office and industrial equipment, pharma, what do you call pharmaceuticals and personal care like syringes, needles, pharma industries, consumer products, building materials, building material, furniture, health care, air and space. These are the end users from the petrochemicals. Here, roles and responsibilities of a chemical engineer in any industry, not only petrochemical or petroleum or pharma or metal industry. What is your role chemical in a chemical industry or any industry? What is the role of chemical engineer? Provide technical support to maintain safe and reliable operations. Very safe plant safety and manpower safety. Man safety, what do you call material safety and machinery safety. All these things comes under reliable operations that you have to provide technical support. Monitor quality of products at all stages. Intermediate stage, initial stage, intermediate stage, finished product stage. You have to monitor the quality of product and implement new ideas to improve efficiency of operating units. Efficiency of operating units. Improve new ideas to improve what you call implement new ideas to improve efficiency of operating units. You have to continuously strive to give what you call quality consistent quality product. Consistency in quality, not only consistency. What you call efficiency means today it is 98.5 means tomorrow it should be 99. In such a way, you have to think how to improve the product efficiency also. Develop safety programs to promote safe working environment. Analyze root cause for operational problems and define solutions. Have to analyze daily what is the problem, why this problem has come, the root cause for operational problems and define solutions. Work with cross-functional teams. Cross-functional teams, you have to work with mechanical, you have to work with quality control and R&D, you have to work with electrical, you have to work with civil, whatever required for the plant, you have to work with all the other functional teams. Run the operating unit smoothly. Implementation and monitoring the ISO systems like ISO 9001, 14001. Continuously strive to meet the company objectives. This is very important. Based on this, what you call your appraisals will be there. Continuously strive to meet the company objectives. Whatever they set the objectives. Here we have to produce 15 million metric tons of naphtha means you have to continuously strive to get that product and to see raw material availability and the equipment availability to produce that much quantity. That is called continuously strive to meet the company objectives. Company will set the objectives for chemical engineer. Chemical engineering department. Follow up with statutory and regulatory bodies for necessary approvals. Statutory and regulatory approvals. Yes, statutory and regulatory approvals means you have to get the pollution control board approvals every year. You have to get the statutory approvals from factory inspector, inspector of factories, and you have to get the what you call Director General of Civil Aviation for aviation turbine fuel, and all these regulatory or statutory bodies approvals every year, and you have to involve in their what you call audit also. Ensure compliance with HSE, health, safety, and environment regulations. There are some regulations, health, safety, and environment. You have to ensure that you are maintaining health, safety, environment regulations. Ensure calibration of the equipment well before the due date. Calibration is very important. When the calibration fails, it may be the quantification failures will come, and not only that one. When the what you call calibration is not okay, the tankage form will collapse. Give the problem. So calibration well before the due date. Once in a year means every year you have to arrange the manpower as well as the technical people to complete the calibration. And after that, you have to verify. You have to check the calibrations whether they are okay or not. Providing training to the technical staff, your subordinates. You have to give technical training continuously once in a month or once in 15 days based on the schedule designed by your organization. And you have some more opportunities in India at present. There are two ISPRL come into the picture recently. Indian strategic, here also you have a lot of opportunities. Indian Strategic Petroleum Reserves Limited ISPRL has come into the picture recently. In Indian government has established Oil Industry Development Board. There is a development board, Oil Industry Development Board, Government of India, under the Ministry of Petroleum and Natural Gas. Government of India is setting up of 5.3 million metric tons crude oil storage in phase 1. This is already completed. Here, Indian strategic petroleum reserves are in addition to the existing storage of crude oil with the oil companies. Existing crude oil storage is already there with the present existing oil companies. In addition to that, and would serve as a option during any global crude oil supply disruptions. Anytime there may be a chance of getting crude oil supply disruptions, because are aware of that, I don't know. I have already told 249.9 million metric tons crude oil capacity. Out of that, in India, we are getting 33% of the demand. Only 33% crude oil is available. 67% of crude oil we are importing from other countries like Iran, Iraq, Kuwait, and other countries. So that's why anytime we may not get sufficient crude oil, any disruptions comes, crude oil disruptions comes, we will not get global crude oil supply disruption. The crude oil storages are constructed in underground caverns at Visakhapatnam, 1.33 million metric tons, Mangalore, 1.5 million metric ton, and Padur, 2. This is also at Karnataka, 2.5 million metric tons. This is already completed and what you call this? This is under, already they put the crude oil into the storage. There is a what you call underground caverns. They will store the crude oil for the emergency purpose. There also the working people are chemical engineers, because they should daily monitor how much the gases are generated, and crude oil properties and oil removal, what you call water removal, settled water will be removed from the caverns. Crude oil crude oil from the caverns can be supplied to the Indian refineries through pipeline. Underground caverns are considered as the safest means of storage of hydrocarbons. The cost of the project was estimated as 2,837 crores. This is completed. Government has given approval in principle. The second phase. This is second phase. Government has given approval in principle for construction of additional SPR. I have already told that storage. ISPRL means I have already told that Indian Strategic Petroleum Resource. Okay. Petroleum Resource Facility of 6.5 million metric tons at two locations, namely Padur, 2.5 million metric tons in Karnataka. Again in Karnataka, the third one, 2.5 million metric tons, and handy coal, 4 million metric tons in Odisha. This is under what you call, because they have to begin the work for this two. One is at 6.55 at Paduru, and handy coal 4 million metric tons in Odisha has to come into the what you call for commissioning. They have to do that work now. Questions and answers, please. Questions, please. I'll give the answers if you have the questions. Here from you, any questions, please, on this particular subject? Very relevant to all chemical engineers because majority of the strength in any refinery is from the chemical engineering community. Chemical engineering people only, the majority people in refineries, that is around 62 to 60 and above percentage of people will be there in refineries, chemical engineers, because they will work in different operating units as well as technical services. Not only that one, even environmental purpose also. I have told HSC, health, safety and environment also, and pollution control board norms to meet their requirement. All these areas comes under chemical engineering department. Not only petrol refineries, even they will work in petrochemicals as well as exploration also. Any questions, please, from the students or anybody? Not clear, please.
Students who have queries, please raise your hand. We will unmute. We will give you the permission to talk.
Is the subject is clear to you now? Hello? Any questions, please? Okay.
Yes, sir. Yes, sir.
May I go to next slide, please? May I go to next slide, please? Can you hear me? Hello?
Yes, sir, you're audible.
May I go to next slide, please?
Okay, sir.
Now the session is feedback from you, from the student community. Feedback. You can give your feedback verbally so that the institute, whether it is fruitful for the students or how much it is useful, that I also should know. Just like that, conducting a presentation and closing is not enough. My intention is all the students, majority of your of the Amrita Vishwavidya Parishad students has to get the Indian refineries because the salary is good and as well as the career opportunity. If you work in the top class Mini Ratna, Maharatna companies, all these companies, so when you get this opportunity, you will have a very better life also. So the intention by keeping Dr. Jayanarayanan Nikhil Karturkar as chairperson of the institute, chemical engineering department, and Dr. Krishna Prasad sir. I have to say so many thanks to Krishna Prasad sir also because he has called me number of times and asked how you have to give this one and all the things because they have done lot of exercise, lot of efforts they put for putting this session in front of you. Even though they might have called to there, but thing is that they want to see online session. Then how it will work and how it will useful, how it will be useful for the student community. It is not when you absorb whatever I have told you in this presentation will help you in the viva or personal interview when you clear the this one what you call it will be very useful to get the opportunity in premium public sector industries, either it is a petrochemical or petroleum or any industry. Definitely you will be selected with this basic knowledge. Now you can give your feedback so that our sirs, our professors also, so many professors are maybe present, I don't know, because they are well versed, knowledgeable people. They might have seen that presentation, and your feedback is very important for the organization because if they conduct and close it, then there will not be any use. Some people they can verbally they can tell what you get from this topic and what you get from this presentation, how it will be useful to you. Or otherwise, you can tell that fairly. If this session is not okay for your chemical engineering community, that also fairly you can tell so that I can understand or any modifications to be done on this presentation. This is what either organization or me required. Even organization also it is required for your Dr. Krishna Prasad sir.
Yes,
Krishna
sir.
Prasad sir also it is
Yes, sir.
required.
Sure, sir. I take the opportunity given to thank our chief guest of the day, Mr. Chiranjeevalu S, for his talk on overview of petroleum refinery. Sir, you have indeed covered extensively on all aspects of downstream and upstream processing of petroleum industry. As you can say, you have made it crisp in a 6 months course. You have reduced it in 2 hours and covered almost all areas of refineries. I thank you for taking time to spend with us on sharing your rich experience in petroleum sector. It was really a good session. Thank you, sir.
Thank you, sir. What I have asked you, whatever I have asked the student community, how much
Ah,
they understood from this part of
yeah.
presentation. That's
Someone
what I
can
asked.
give a Sugisan.
Some
Sugisan, can you
some
give a
people,
feedback?
some students, if they tell
Yeah,
their
I taken it.
version, then we can understand. You or me
Yeah, yeah.
can. I think you know, just now Krishna Prasad sir might have talked. I think. Am I right?
Sugisan, can you give a feedback? Sugisan.
Yes, sir.
Some people can give feedback so that I can understand as well as the our institute can understand this how it will be helpful to you.
The session was extensively covered, sir. It covered
I
most of the
have not.
topics that we.
I am. Yeah. I am not doing just for any my personal purpose or something. It has to work for the student community, especially. Yeah. Now you can tell.
The session was extensively covered, sir. It covered most of the topics that we studied, and it was very informative in a from petroleum refineries. We learned a lot today, sir.
That's no what you read.
Anybody?
Abhiram, are you available?
Sir, it was
Anyone
good to see.
can
It was good to
raise your
see
hands. If you raise your
PFDs
hands,
and
you
all
will
those
come to
things.
the top. You can raise your hands. Anyone can raise your hands. There are so much attendees. You can raise your hands and you open your mic will be provided. You can talk. Anyone can raise. Okay. You can. I hope you know raising hands. Raising hand. That is a third button. Third button. You press it. You can raise your hands. Okay. Okay. Sugi-san, can you take up the session further?
Hello?
What's the next? Sugi-san.
Can I close it, sir?
Hello, sir.
Sir? Hello?
Now we invite Karthik for the vote of thanks.
Right. Thank you, sir. Thank you for all the people who are attending for this session, and best of luck for all the students.
Yes. On behalf of our college, I would like to express our sincere gratitude to Mr. Chiranjeevalu S for gracing our event as the esteemed speaker. We are truly honored that he took out his time out of his busy schedule to share his expertise and insight with us. His valuable knowledge on crude oil classification, important properties, and process units and finished products has undoubtedly enriched our understanding of the industry. I would like to extend an additional note of gratitude to Mr. Chiranjeevalu S for his illuminating session on the topic of crude oil. His comprehensive insights into crude oil classification and important properties associated with it were incredibly valuable. By dwelling into the intricate details of the process, units involved in refining crude oil, and producing finished products, he has given us a profound understanding of the industry's inner workings. Mr. Chiranjeevalu's ability to simplify complex concepts and present them in an engaging manner made the learning experience all the more enriching. His expertise in this field is truly commendable, and his willingness to share this knowledge with us exemplifies his commitment to education and industry advancement. Furthermore, on the emphasis on the significance of each type of the finished product derived from the crude oil and their role in various sectors of the industry highlighted the real world application of the knowledge we gained today. This exposure to the practical aspects of the industry will undoubtedly prove invaluable as we embark on our professional journeys. I extend a heartfelt thank you to our head of department for his dedicated efforts in organizing this event. His vision and dedication have been instrumental in making this event a success. It's important to acknowledge the exceptional support we have received from all our staff members. Their cooperation and hard work have contributed significantly to the smooth functioning of the organization. Furthermore, I would like to express my appreciation to all the students who attended the session, actively participated in the discussion. Your engagement shows your commitment to learning, and your enthusiasm for gaining industry insights. This event would not have been possible without each and one of you. In closing, let us continue to learn and grow from such experiences. And may we continue to foster an environment of knowledge sharing and collaboration. Once again, a heartfelt thank you to Mr. Chiranjeevalu S, our head of department, our staff, and our fellow students for making this event a memorable one. Your contribution are deeply appreciated. Thank you.